Okay? So if you're ever out, sometime that day, the lesson, if we're doing notes, will be posted on Blackboard. Okay? Always. Okay, so on the top of page 48, so we are studying quadratics, and another name for the graph of a quadratic is a parabola. So we are quadratics, and it is a parabola. Now, one of the things that you need to realize that Math Excel will do, okay, and you will see it throughout the notes is written differently, okay? Normally, when we graph a line, it was y equals something, okay? So you could see this as y equals x squared. Anything that has a square in it, okay, so it has your variable squared, is going to be a parabola or a quadratic. Okay? It also writes this as f of x equals x squared. Okay, this is the same thing. These two say the exact same thing, and it just depends on how Math Excel decides to write it out for you. Okay? So what you need to understand that whenever you see f of x, that is going to be the same as if it is a y there. Okay? So I've had students in the past that don't like that f of x, and so they go through their paper and they put y's there because that's the way that helps them. If that helps you, that's fine. You can't do it on the computer screen, but you can do it on your notes. Okay? Or just start to realize when you move forward, most of you will be taking another math next year. Okay? And depending on the math that you decide to take next year, you could make the transition that everything says f of x, and you no longer have the y equals. Because as you move forward in math, things change and you use different notation. Okay? So same thing as in English. Okay? When you first learned to write a sentence back in elementary school, and now what have you done? You've added to it each time to make your sentence, your first sentence that Joe plays baseball. Now you say something a lot different than that. Okay? No simple sentences anymore. So same with math. It gets a little bit more complicated the more math you do. Okay, so we are going to look at this equation here. The equation that we are going to graph is y equals x squared. And the reason why we're going to look at this graph here is because this is what's called your parent graph. Okay? Every one of your quadratic graphs will look exactly like the graph that we're putting here. The only thing that will be different is where I start from. Okay? So this one is going to start at 0, 0, your origin. Okay? Now, we're going to start by doing a table because we looked at tables on Monday and Tuesday. So the table for our x column, we're going to put -3, -2, -1, 0, 1, 2, and 3. Okay? And why did I pick those numbers? Because if you get any larger than 3 or -3, you have to have a really large graph. Okay? And I don't want to have any larger graphs than what I have here, or to explain further. Okay. First of all, let me ask you, is this parabola going to be a function? And how do I know it's going to be a function?
Yes, because x isn't repeated.
Correct. So if I look at this x column, it is not repeated. Any of the numbers are not repeated, so this will be a function. All quadratics are functions. Okay? Now, to figure out your y value, you're going to take the -3 and you're going to substitute it in there for x. Whenever you put a negative, you have to, if you're going to use your calculator, you have to put it in parentheses. Okay, so if you're using your calculator, you're going to put parentheses, -3, close your parenthesis, and square it. If you can do it in your head, great too. So -3 squared is -3 times -3, which is 9. Okay? Then we're going to put -2 in here. What's -2 squared? 4. What's 1 squared?
1,
0 squared.
0,
0 times 0 is 0. 1 squared. 1 times 1?
1,
2 squared. And 3 squared.
9,
Right? So basically, a quadratic is just squaring numbers. Okay? Now, these become ordered pairs. So we're going to look at these ordered pairs and we're going to graph each one of them. Okay, so the first one, we're going to start at your origin and we're going to go left 3 and up 9. Okay, I'm going to go back to my origin and I'm going to go left 2 and up 4.
Are we connected to that?
Eventually. I'm going to go left 1, up 1. 0, 0 is right there at my origin. So I'm just plotting these points. Everybody should be able to plot points. I'm at 1, 1, so I'm right 1, up 1, 2, 4, and 3, 9. So I have those 7 points. You will not have to graph 7 points every time. You will not have to graph 7 points on the computer. We'll talk about that as we go through. Okay? Now, this is a parabola. Some people like to say parabola for a parabola because this is not straight down. This curves. So it has a nice curve to it. That's the reason why you don't have straight edges, because you need to put that as curving. It does not come to a point. Okay? So do the best you can with that. When you do Math Excel, there's 2 different tools there. One is a line tool and one is the curve tool. Obviously, you're going to choose the curve tool to be able to graph the quadratic. Okay? Okay. When we move forward, and I'm going to highlight them. If you don't have a highlight, maybe you just put boxes around those. Those are the 4 points that you have to memorize. Okay? And this is the reason why you memorize them. Because the only thing that changes with the quadratic is if I could physically pick this up and move it to a different location. Okay? These points will always be the same. Okay? Until we get to after break, we'll add another piece to it. But for right now, these points will always be the same. Okay? And the reason why we're not going -3, 9, and 3, 9 is because usually the graph paper I give you only goes out to 10. Okay? And the same on Math Excel. Okay? So, you memorize these points and you can graph every single quadratic that I ever give you. Okay? And we'll talk about that, and I will put them up there on the board sometime this week.
What was the name for the calculator on? Again?
This graph?
Yeah.
This graph is a parabola.
Oh, what was it called? Is that what we called it yesterday?
Yeah, yesterday I was just saying quadratic.
Uh,
Okay? Okay, is this a function or not a function?
A function.
It's a function. We already talked about that x column. Nothing is repeated. Okay? So this is a function. We talked about this graph, a quadratic, on Monday.
How do we
And
know if it's a function or not again?
vertical line test, or as long as your x values are never repeated.
Like, how are we supposed to know if they never repeated?
Well, because I looked up here at the table, and this arrow is going to the left, and this arrow is going to the right. So when they're going in opposite directions, that's going to be true. Okay, and I said this on Monday, and I said it again yesterday, and let's see who remembers today. Every quadratic
all real
has the
numbers.
same domain,
All real numbers.
all real numbers.
All real numbers.
So the domain will always be all real numbers.
I just put the R.
That's fine.
Am I got a game today?
Now, the range. The range is not going to be all real numbers. And the reason being because these arrows are only going up. Okay? They're not going in opposite directions. So if they're only going up, your range has to start somewhere and then represent all the values that would be going up.
So is it y greater than 0?
Y
It's
is greater than or
greater than or equal to. So y is greater than or equal to 0. So
How you know that?
it's always going to be equal to,
How
okay?
you know that?
Because what's the lowest y value I have? I have 0, and then everything going up from there, because my arrows are going up. So the numbers that are higher than 0 here are 1, 2, 3, 4, 5, 6. Those numbers are greater than. So we would have greater than or equal to.
Or is it the line? Is it greater or equal to because the lines are solid?
Correct. And we're not going to study them where there would be a hole there. You can. That would be pre-calc if you took that next year. Okay? Okay, so here are the rules for graphing any function. Okay? So these rules, we're going to specifically study quadratics. So we're going to use these rules for quadratics. But if I would give you a cubic function, or a square root function, okay, or an inverse function, these exact same rules would tell you how to graph that, okay? So these rules are universal to any function that you graph. Okay, so above this, on this box, y equals x minus h. We're going to put,
Right there.
yes, and I added something there. You don't have to have it. If you didn't put the A in, that's fine.
Let's say H.
It says H and a K and an A. Okay. For the time being, we are not doing anything with this A out here. Okay? That will be when we get back from winter break when we start quadratics. So we can ignore it. Ours are not going to have any number out in front of the parenthesis. Okay? Now, you have to be able to identify inside a grouping symbol and outside a grouping symbol. So what's the grouping symbol in this problem here? What's the grouping symbol?
the parentheses.
The parentheses. Parentheses are grouping symbols, okay? So you have what's inside, this would be inside, x minus h, that's inside a grouping symbol. The plus k would be outside the grouping symbol. Does that make sense to you? What's inside and what's outside? Okay, so when I'm looking at, it says in general, when a number is outside of the grouping symbol. So outside would be this k value here. It's going to move the graph up if it is being added. So for instance, here this says plus k, so it would move the graph up whatever k was.
So down if it's being subtracted.
And it's going to move the graph down if it's being subtracted. Okay, so if this said minus k, it would move it down however many k was. Okay. Now, inside tends to be a little bit harder. Okay? So when you're looking inside the grouping symbol, which is this x minus h here, that's inside. Okay? It's going to move the graph right if it is being subtracted. It's going to move the graph left if it is being added. I'll write it over here.
It's right over there. But that's it. Opposite.
I tried to squeeze it in there. I put opposite of what you think. Okay? Because if something's being subtracted, you would normally go left. But inside the grouping symbol always point slope. We did the opposite what was in the parentheses. Okay. Okay. And 3 says, in general, if there is a negative with the parent function, so the parent function is y equals x squared, if you're confused what that means, that's your parent function. It reflects the graph. In other words, instead of the parabola opening up, the parabola is going to open down. And I'm going to put a little additional piece there, so you'll need to write that in your notes here. Okay? So if the equation says f of x equals x squared, that parabola is going to open up. So this opens up. If it says f of x equals negative x squared, that parabola is going to open down. So the negative tells you to reflect it. And what I mean by that, and I'll let that see, this opens up, correct? Now it opens down. The arrows will go down. That's the only difference, okay? So every graph that you get will look like this. The only thing that will be different is where you start this point from. Questions on this?
No.
Here? Not yet? Okay. Oh, okay. You need that there? Is that good? Okay, so we're going to, today for the rest of our notes, we're going to do 2 things. One is we're going to verbally translate what's going on, and then 2, we're going to graph it, okay? And then tomorrow we'll add another piece. Okay, so if we start with problem number 2. Okay, the first thing you're going to ask yourself is which way is this parabola going to open? Up or down?
Up.
Up. If there's not a negative after the equal sign, it will open up. So we're going to write that. We're going to just say opens up. Okay, then we're going to ask ourselves, it has +2. Is that inside or outside?
Outside.
It's outside, right? There's no inside here. There's no parentheses. So it's outside. So the plus tells you to go what direction? Up or down?
Up.
So we are going to go up 2. So that's the movement. The graph is going to open up, and it's just going to be picked up and shifted up 2. So we are going to start at 0, 0, but not put a point there. And my directions just said go up 2. So I'm going to go up 2 and put my point.
Will we go left too because of the x being positive?
No.
No?
So right here, if I was telling you how to get from my room to, or let's back up. If you were telling me how to get from my room to your lab, you would have to tell me up and down steps, turn left, turn right, and it falls, right? So that's what you're doing here. You're telling me to take the point that should be at 0, 0 and move it up 2. Okay? From there, I'm going to put the table from the front just because I can't show you both at the same time. You have it already, but you might want to write it down again. Those were the 4 points that I told you you had to memorize to draw this graph. Okay? So, from my new point here, from this new point, the first point is -2, 4. So from here, I'm going to go -2, which would be left 2, and then up 4. That will be my new point. Go back to where you start. You always go back to your starting point, and I'm going to go left 1, up 1. Left 1, up 1. Go back to where you started. The next point is 1, 1. Go over 1 and up 1. And then go back to that starting point one last time, and you're going to go right 2, up 4. And then draw your parabola. These points here, those 4 points, will be on every parabola that we're studying from now until January. So the only difference is from what I did on your other page. The only difference from this parabola here to this parabola is that I shifted it up 2. So I took the parabola and I moved it up 2.
How did you get the order pairs?
Because I know negative 2 squared is 4. I know negative 1 squared is 1. 1 squared is 1. And 2 squared is 4.
How did you get negative 2?
No, she said we gonna be using this graph off the front of our page, so remember those two. That's why she wanted us to separate.
Yep. That's why I highlighted those, because those are the points that you just need to memorize. Okay? Okay, so we're going to skip to 4.
I did this one.
Okay, number 4. How does it open? Up or down? Those are your two choices.
Down.
4. Number 4.
Oh.
Not number 3. Number
it's
4. It opens up.
Oh, because it's the thing.
Yeah, I skipped one. I skipped 3 and went to 4.
I'm guessing there's a reason.
Now, negative 3 or minus 3 is inside a grouping symbol. Okay? So if you look at your rules and you are subtracting inside a grouping symbol, which way do you go?
Right.
Right. So I'm going to go right 3. I have my directions now. My directions say from my origin to go right 3. 1, 2, 3. Put a point.
When it's on the grouping symbol, you go right. And when she said opposite,
All I'm doing is rewriting the same table so you could see it again. You don't have to keep rewriting it in your notes if you don't want to. Okay? From this, graph those 4 ordered pairs again. So from this point, I'm going to go left 2, up 4.
How do you shift it over 2 or 3 spaces?
3. Left 1, up 1. Always start where you moved your point originally. Right 1, up 1. Go back to that starting point. Right 2, up 4.
We doing other ones by ourselves?
No, we're doing them together. We have time. We're going to do them together, and then we're going to stop for today. So we're going to finish 3 and 5. Okay, while we're waiting on everybody to finish up on 4, look at 3 and see if you can figure out how it's going to open.
Down.
Okay, why, Jonna?
Because it's a negative.
Correct. There's a negative out. Right after that equal sign, there's a negative. So it's going to open down.
So we're going left.
Inside the grouping symbol says plus 1. So if you're adding 1, you're going to the left 1. Remember, inside a grouping symbol, you're always going to go the opposite way you think. So normally when it's plus, you go to the right. You got to go the opposite. Okay, so starting at your origin, 0, 0, I'm going left 1, and I'm going to put a point. Okay, now we have to think, because here's our points, right? Negative 2, 4. So when I go to negative 2 for my starting point, if I go up 4, is my graph going to open down like I said? No. So when I go left 2, which direction do I have to go now?
Down.
Down 4 because it opens down. So left 2, down 4. Go back to your starting point. When I go left 1, which direction am I going to go for the next point? Do I go up 1 or down 1 again? Back to that starting point. When I go right 1, I'm going to go down 1. Back to your starting point. When I go right 2, I'm going to go down 4. So it's the same points. When you determine if it opens up, you're going to go up with your y value. When you determine it opens down, you're going to go down with that y value. Okay, 5 puts all of the pieces together. So 5 is going to be open which direction?
Down.
Yes, it's going to open down. Okay? The -1, which is inside the grouping symbol, is going to tell you to go what direction?
Left.
Right.
No,
Right. So it's going to tell you to go right 1. And then the +3 that's outside is going to tell you to go up 3. Yes?
Why does it open down?
It opens down because of the negative after the equal sign. So if there's a negative after the equal sign, it will always open down. Okay? Okay, so our directions are from my starting point, then I'm going to go right 1, and then I'm going to go up 3. So that's my directions. And then when I go left 2, it says 4. Go down 4. Go back to that starting point. When I go left 1, I'm going to go down 1. Back to the starting point. When I go right 1, down 1. And last point, when I go back to that starting point, I'm going to go right 2, down 4. That one's kind of sloppy.